Hello, Visions, and welcome to this session of the Virtual Curriculum Fair. I am joined with Kathleen, who is going to be presenting on RightStart Math. So, Kathleen, I'm going to have you go ahead and take the floor.
All right, thank you. Thank you very much. Again, I'm Kathleen Cotter-Clayton, and this is a presentation. I'm going to try to, I could talk like for hours. So I'm going to try to talk as fast as I can and cover as much as I can in the time that we have allotted. So if I talk fast, I apologize. So I just make you listen fast. We're going to talk about unlocking the puzzle, the math puzzle with RightStart Math. So often, if I get my mouse to work here, there we go. So often math is just a mystery. It's a puzzle and there's a lot of interlocking parts, but so often it looks like this. And the kids struggle with it. It's faint, it's fuzzy, it's unclear. But there's actually five very strong components that will make a difference with unlocking the math puzzle. The first one is subitizing. Subitizing is the ability to quickly recognize a quantity without counting. For example, if I put this many fingers up, nobody has to count it. You can see that it's three. It's right there. It's three. That's subitizing. Or if I do this, there's seven. Again, nobody had to count it. 1, 2, 3, 4, 5. You can see that it's seven. Now, young children have to be taught that this configuration or this quantity is called seven, but again, they don't have to count that it's seven. They can see that it's seven. And that is a skill that is taught in the RightStart curriculum. And you're going to see as we go on, that actually becomes a very handy skill as we get going. Now, one thing with this, when you look at a hands, they're actually grouped in fives. And that's important because if you don't have grouping in fives, like if I have this many apples, how many is it? Well, I don't know. You'd have to count it. But if I group it, oh, you can see that there's 5 red and 3 green. Now I can see my quantity. I can subitize it. I can see it. And this grouping by fives, this isn't like something weird that we just came up with ourselves. I mean, we do it with clocks, we do it with money. Even the early Romans did it. Now, this is the early Romans. Instead of 4 being 1V, it's 4 ones. But again, after 4 ones, they just didn't keep putting ones as they went along. 5 has a different character, in this case, the V. So again, you've got grouping. And so we've been doing this. One thing that if you kind of look at this, I'm going to pick on colored rods. I'm not picking on a program, but I am going to pick on colored rods because there are programs that use colored rods. And the problem with that is, again, I can't see the quantity. I can't see what it is. And then never mind that some of the children are color deficient, formerly known as colorblind, and they can't see the color. So they'd have to memorize this color means this, but again, they can't see the quantity. We need the grouping just like our hands are grouped. So this was 8, and so is this 8. That's hard. This is easy. So we need this subitizing. That's the first piece of the puzzle with math. The second thing is the Cotter Abacus. And of course, we're going to be using this in the RightStart Math program. The Cotter Abacus is a visual and tactile manipulative that helps the children develop mental images of quantities, strategies, and mathematical operations. Ben Pridmore, who's a world memory champion, says, think in pictures because the brain remembers images better than it does anything else. So in other words, we think in pictures. Let's give this to the children so that they can see the pictures, which again comes back to that subitizing. So let's look at the abacus here. So I'm going to have the abacus. I'm going to have my child. I'm going to say, okay, ready? Get your hands ready. Show me 3. And the child's going to show 3. And from here, I'm going to put on 3 beads. And this is my symbol 3. So this is not 3. This is the symbol that represents 3. This is actually 3. And it's like, really, Kathleen, you're gonna make a big deal about this? Yes, this is huge. If the kids do not understand what 3 means, if they don't have number sense, if they don't understand what 3 means, everything gets really weird from here on out. So we want them to understand that this is the symbol, but this is what 3 is. Okay, so we're going to clear on our hands, get them ready, show me 5. So again, all the fingers on one hand, just like it's all the beads of one color. So we can see 5 and my symbol 5. Clear. Here we have, again, get your hands ready. We have 7. Now, if a child is young or slow with it, I'm going to be very quick so they can mirror it to me, so they can see it. If they're fast at it, I'm going to say 7. They show me 7, and I'm going to mirror them slower. I'm going to move slower with it. So again, they're beginning to lead. Now, this is going to be my blue. This is going to be my yellow. So I can put 7 on without counting. In other words, again, I can subitize it. I can recognize that quantity again because it is grouped. My symbol 7, clear, and 10. Oh my goodness, we love 10. All the fingers, all the beads, and we love 10. So let's start to use this now with some addition strategies. Here's my abacus. If I have 5 plus 2 equals. Now, some kids don't know what plus means. They either gapped out that day or they never quite got it. So we'll use the word plus and we'll kind of use them interchangeably. So 5 and or plus. So again, see how I'm using both terms. 5 and 2 more is or equals is, oh, I've seen that before. That's 7. I don't have to get in with finger counting. I don't have to do 5 plus 2 is let's see. Oh, wait, what was the question? I don't get that confusion. I can see it right there. And remember, we think in pictures. So it's going to be 5 and 2 more is, oh, I've seen that before. That's 7. So here we've got, let's do another one here. Let's do 4 plus 3. 4 plus 3 more is or equals, push it together. Oh, that's also 7. That's really cool. So we can see that. But so often, this is how our kids are taught. They've got a typical worksheet where I've got 4 horsies and 3 horsies, and somehow they're supposed to figure out from there that that's 7 horsies. Really, it's not visualizable. I can't see this in my mind. And it's an exercise in just counting horsies. It doesn't help me understand that 4 plus 3 equals 7. Here's my facts that equal 10. I have 1 and 9, 2 and 8, 3 and 7, 4 and 6, and we keep going with it. And again, you get these images in your mind. The next piece for unlocking the math puzzle is games. And games we put in the center because everything spins around the games. Very simple game that we're going to start out with. It's a go to the dump game. It's called go to the dump. It's a go fish type of game where the pairs, remember how to play go fish? You want the 4 to match a 4 and the 3 to match a 3. It's not really rocket science. We want our pairs to be things that equal 10. So 1 and 9, 2 and 8, 3 and 7. Using these cards, very simple cards, and my abacus. So if I have a 7 in my hand, 7 needs needs a 3. So mommy, do you have a 3? No, go fish. It's a worksheet. The kids will play it for hours to the point that you will cheat to lose to get out of there, but they love the game. It becomes the worksheet. It's like a live worksheet that they can work with, and they love it. There's also an app for the game. We have an app for your devices. Now here we call it Go to 10, just because if we call it go to the dump, that just gives a whole different weird thing when you're looking online for it. But so here we call it go to 10. And this, personally, I'm not an advocate for having kids on screens, but there are times when it is very appropriate. So again, they can be playing this game instead of maybe having cards flying all over the dentist office or something of the sort. So why are we focusing on games? Well, games are to math like books are to reading. Games provide the repetition that's needed for those automatic responses in a social setting, but more importantly, games provide an application for the new information. It gives the kids a reason to want to learn their facts. So that's why we play the games. It makes it interesting and fun, and it brings the joy into it. And by the way, I did not say that games are a reward. Rather, games are the repetition so that the kids get good at it. Another thing that's integral into the RightStart Math program is the math balance. Now, normally when I'm giving this live, I like to share an actual balance. We don't have the time and the ability to do an actual balance. Excuse me a second, to do an actual balance. So I'm just going to show you real quick. What it does is if I hang the weights on a 3 and a 7, it balances with 10. Why? Because 10 equals 3 plus 7. If I get it wrong and I think that it's actually 9 equals 3 plus 7, it won't balance. So all I have to do is just look at the child and say, is that balanced? And again, they get the immediate feedback so that they can do it correctly. The math balance we use throughout the program because it gives a different way of looking at things. So you're looking on the abacus, you're looking at with other manipulatives. We actually have over 20 manipulatives that the children are using in the Right Start Math program along with the games. Okay, so we've got the subitizing, we've got the abacus, we've got games, and there's something else that we do that is really, really powerful, and it's different, but it is so good. Now, I want to take a second and talk to you about this. This is transparent number naming. So here I've got my abacus. I put this on, there's 10 beads. If I do this, most of you are saying 20. Well, yes, it is 20, but for a short spell, and when I'm talking short spell, I'm talking about 3 months for your kindergartners, your first graders, and then your second graders and third graders are doing it for about a week, and the older kids are going to do it for about a day. But instead of calling this 20, we're going to call this 210, right? Because it's 10 and there's two of them, so 210. Again, just a short-term thing. We're not going to be weird. We're going to come back to calling it 20. This is just a short-term thing. So this would be, say it the math way, 210 4. This would be 210 8 and 310, 310 6. So why are we doing this? Well, let me first walk through real quick what it is. Again, we're going to go 10 is normal. 11 is where it starts to change. 11 is going to be 10 1, 10 2, 10 3, 10 4, 10 5, 10 6, 10 7, 10 8, 10 9, 210, 210 1, 210 2, all the way up to 9 10 9. So it's only from 11 to 99 that our language has screwed up because we're going to do this for two reasons. The first reason is patterning, because you think about it, we say 3,000,000, 3,000, 300. Why don't we say 310? Oh, yeah, our language does handicap us. So we show kids, here's the pattern. And so they can see again, 3,000,000, 3,000, 300, 310. They can see the pattern with it. Oh, the real way of saying 310 is 30. Okay, got it. But now they understand. They kind of become bilingual. The other reason we do it is for place value. If I have 310 on here, here's my place value cards. I can use my syllables to help me with the placement. 310. So that 0 is what's making that 3 to 310. This would be 310 7. Here's my 310 place value card, my 7 card. The way I write the numbers, I put the 7 on top, aligned to the right-hand side, and now I have 310 7. And if I get confused, what's that 3? I can pick that 7 up and go, oh, that's okay, right, 310 7. Now, think about this. If I ask you how many tens are in 310 7, how many tens are in 310 7? You can hear it right in what I'm asking. It's kind of like if I say, what's your name, Bob? You can hear it. It's right there, 310 7. Of course, there's 310. But if I say 37, can you hear how many tens are in there? Just listen, 37. Yeah, you can't hear that. And that's a problem. So again, our language handicaps our children. So we remove that handicap, use this transparent or math way of saying the numbers for just a short spell until they understand how the numbers go together. So this would be 610. Notice the color change down here. So I've got 5 and one more 10. So I have 610. Here's 610. Here's 610 2. Again, how I write it, here's my 610 and my 2. I put the 2 on top, 610 2. Oh my goodness, we love this one, 10 10. Here's my place value cards, 10 10. Also known as, watch my place value, 100. Again, I'm using the syllables to help me with the placement. So I've got 810, 800. And once again, the English language throws us a loop and we have to do 8,000. So thanks, English language. We appreciate the confusion. Okay, so here we've got 3,600, 510, 8. And again, if I get confused, what does this 6 mean? Oh, that's right, that's 600. I can see that. Here's another one. Here's where I have 400, 9, 10, 2. or excuse me, 4,910, 2. So 4,092. And so often, not having something in one of the places with a zero really throws kids. With the place value cards, it's not a problem. So where did this crazy idea come from? This actually came from the Asian languages. The Asian languages use this math way of saying the number naming. And it's interesting. Children the Asian speaking children understand place value in first grade, whereas only half the US students understand place value at the end of fourth grade. So this is what we want to do is we want to use this again just temporarily because math is a science of patterns, and the pattern math way of saying the numbers helps the children learn their number sense. Last thing I want to cover, well, actually, to take it back, we're going to talk here about combining the pieces real quick. A strategy is a way to learn a new fact or to recall a forgotten fact. And if I can make it visual, because remember, we think visually, that's a very powerful strategy. 9 plus 5, this first one is called complete the 10. 9 plus 5, 9 on the first row, 5 on the next. I'm going to complete the 10. I'm going to trade these two beads. 1, 2, 3, trade. Answer is 10, 6. Excuse me, sorry, did that wrong. 10, 4 or 14. So again, see how that math way of saying the numbers helps me with this strategy. Here's another one. This is my personal favorite. This is the 2-5 strategy. 8 plus 6, 8 on the first row, 6 on the next. Before I do anything, can you see the answer? Look at my blue beads. There's 10, and the yellows, 4 more. 10, 4 is 14. Do another one real quick. 7 plus 5, 7 plus 5. Look at how fast you can see the answer. You can almost see the answer before your mouth comes up with the words. So my answer is going to be 10, 2 or 12. We can do multiplication on here. Here I have 6 taken 2 times. So I have 6 times 2. I can see my answer is 12. Here's 6 taken 4 times. Okay, a lot more beads, but look at this here. We've got 10, 2, 10, 24. Isn't that cool? 5 times 7. Again, let's group by tens. Here's 10, 2, 10, 3, 10, so 35. I could also do it this way because I've learned over time that this is 25 and 10 more makes 35. 9 times 3. I could trade and come up with the answer of 27. But what if I do it this way? What if I say how many beads are on these 3 rows all together? There's 30 minus 3 is 27. Use the same strategy again. 9 times 7 is going to be, 70 minus 7, which is 63. Quick game, just to show you real quick, a multiplication game. It's called Ring Around the Product. Product is the answer for a multiplication fact. So I've got my multiplication cards. I ring them with my basic number cards, my numbers 1 through 10 in random order. 54 needs what two cards multiplied together is 54? 9 and 6. Scoop them up. 12. 12 needs a 3 and a 4. I don't have a 4. Oh, I could do 2 and 6. Again, it's a worksheet. The kids will play this for hours, and that's what you want them to do. This is the practice and the review, and they're having fun with it. Last thing I want to talk about here is the linear fractions, because fractions, that's so difficult for children, but not when you do it with the linear look. So this is my fraction chart where I've got linear. So I've got 1 broken into 2 equal pieces. We call them halves. 3 equal pieces, thirds. 4 equal pieces, fourths. Fifths, sixths, sevenths, eighths, ninths, tenths. Look at the patterns in here. Isn't that pretty? You've got these patterns. You've got all these really pretty patterns in there. How many fourths are in a whole? Now, we could subitize it, but I'm going to count it out. 1, 2, 3, 4. So you can see 4 fourths in a whole. How many fifths in a whole? 5. How many eighths in a whole? 8. I have met teachers who do not know what the answer to this is. It's amazing what people don't know, but again, it's not because they don't know it, it's because they were never taught it well. With the fraction chart, it's so easy. We can do things like what's more, 3/4 or 4/5. Here's 3/4, 4/5. Obviously, 4/5 is bigger. Let's do another one here. What's more, 7/8 or 8/9? 7/8 or 8/9? Ooh, 8/9, just by a little bit. We could take a partial chart, and I've just got the ones, halves, fourths, and eighths. I'm going to erase my horizontal lines and my little green numbers. What is it? It's a ruler. So we can play games practicing this. Now I'm going to do something real quick. I just want to show you guys just some of the joy in math. It's just people don't you think like fractions and joy that doesn't go together? Wait till you see this next thing. I'm going to erase these. If I put in 100, what's the next line going to be? It's going to be two 50s. Next line, 25. Next line, 12 and a half. So if I have 100%, I can see how 50%, 25, 12.5% are all related. What if I have it as 100 cents, 50 cents, 25 cents? Well, we don't really do 12.5 cents, but I could do 10 cents. I could do it as 60 minutes. What's half? 30 minutes. What's a fourth or a quarter of an hour? It'd be 15 minutes. What if I do it as a gallon? Here's a half gallon. Here's a quart. And then pints. If you want to, you can add in cups. But see how they're all related. Here I've got a whole note, half note, quarter note, eighth note. We can do simplifying fractions. 5/10 is the same thing as 1/2. 4/8 is the same thing as 1/2. 3/6, 2/4. So we can show the children how simplifying fraction works. One last one real quick. What's 1/2 of 1/2? So here's a half. Half of that is a fourth. What's 1/3 of 1/2? So here's my 1/2 again. Break it into 3 equal pieces. It's 1/6. You guys just multiplied fractions and nobody cried. Isn't that just awesome? It's so neat to see how this RightStart Math program works. It's now a well-established fact that those who are mathematically effective in their daily life seldom make use in their heads of the standard written method that's taught in the classroom. In other words, the smart math people aren't doing it the way that you and I are taught. The smart math people are doing math a different way, and that's what RightStart Math is. This is going to get your kids understanding math and loving math and being able to work with math. We have the program so that we start with level A, B, C, D, E, F, G, H. You can start at any point in there in the curriculum. You don't have to start in the beginning. So let's say you've got a program, it's not working well. You can start in level D. Level D is where we do multiplication. So like I said, you can see where you need to be and we can help you place if need be. We use the abacus for visualization. We teach topics in different ways. Fractions are presented linear. We use games, 20 different manipulatives. And as I said, we have levels, not grades. Here's what a lesson looks like. We've got objectives, materials. Here's the teaching. And this over here is notes to you. These are explanations. This tells you why you're doing, what's the research behind it, what if your child's struggling, what if they're gifted. It gives you different ideas with it. So you really just need to look at the activities. This just enhances it for you. Placement, again, we do have a placement test, and again, we can run through that with you or one of your, like I said, let us know what we can do to help you. I'm just going to actually, I'm going to skip through this real quick. It's got some good stuff, but I also want to let you know too that there is another program called RightStart Tutoring. What we did with this is we distilled, in this particular case, number sense, we distilled all the addition and subtraction information lessons out of levels A, B, and C. Put it in here. This is for a child who's 2 years or more behind where they should be. If they're 1 year behind, they can go into RightStart Math. But if they're 2 or more years behind where they should be, they can go into tutoring. And then depending upon how old they are, they'll go into the RightStart Math program once they're completed with each section. So number sense, this is going to do simple addition, simple subtraction, 4-digit addition, and 4-digit subtraction. 50 lessons, no worksheets. The kids will be devastated, but they'll be fine. But no worksheets, and every time we're playing games. Every day we're playing games. The next book is Multiplication Division Book 1. So this does 1 times 1 to 10 times 10, and then division from 100 down, including remainders. Again, this one I think has 59 lessons. And again, no worksheets and a game every day. Book two, multiplication division, book two is going to do multi-digit multiplication, short division, and long division. Again, no worksheets. Last one we have is Right Start Tutoring Fractions. This one does have worksheets, but they're more exploration rather than review. This one starts out with golly gee whiz, what's a fraction? And it goes all the way up to multiplying and dividing fractions. I'm going to skip over these real quick. In conclusion, math needs to be taught so 95% is understood and only 5% memorized. So often that gets turned around. We want the kids to understand so that they can figure out what to do, because math isn't just to know what 8 times 7 is. Math is a tool so that they can advance in their life, so they can solve future problems. Because I can't possibly teach the kids everything they need to know because we don't know what's coming. And so they have to be able to take these tools and run with them. Dr. Cotter says our goal as a teacher of mathematics is to help our children transform, expand, and refine these beginning ideas into deeper mathematical thinking. So what questions can I help anybody with? I know that was a lot really fast, but hopefully I can help somebody with something, a question.
Absolutely wonderful. Thank you so much.
Oh, thank you.
We do have just a minute here for questions. I'm going to go ahead and stop our recording at this point so we can move into that.
Okay.